you see my slide?
I can. Perfect. Have a great session.
Thank you. I'm Kathy Kellenberger, a senior consultant with Pragmatic Works, and I'm here to talk to you about writing better queries with window functions. In that first slide, I always have a hard time advancing it. There we go. So many of you may be using window functions and not even realizing that you're doing it. I didn't even hear that term until maybe a year ago, but there were several window functions introduced in 2005. Then there were new window functions and also some enhancements in 2012. What I found was that I was giving a presentation on new T-SQL features for 2012. I was giving that at a lot of user groups and SQL Saturdays around the country. And when I got to the new features of 2012, the window function piece, a lot of people had no idea what had actually been introduced in 2005 or didn't know all of it. So if you have used the row number function, you have actually used a window function. And this has nothing to do with the Windows operating system. This window that we'll talk about is actually part of an ANSI standard. I'm not sure how long it's been out there, but Microsoft began implementing it in 2005. Just got a message about color screen, so let me go back and hopefully you can still see my screen.
Yes, Kathy, I can still see it. Yep.
Okay. That weird message came up and I didn't know what was going on. Okay.
Yes, and it may come up again. If you'll just click the last one, then you shouldn't see it again.
Last one.
Yep.
Okay, great. Thank you. So what I found was I was giving this presentation on just the new T-SQL features with 2012, and a lot of people got lost when I got to the window function enhancements and realized I needed to have a presentation just on this, and starting with the 2005 implementation. So that's what this is about. So what we're going to cover today is explain what exactly is a window function. First piece we'll talk about is the ranking function, and I would suspect that many of you out there have used those, at least row number. We'll talk about window aggregates. Again, this is something that was introduced in 2005. A lot of people don't know about. And then we'll move on to the enhancements with 2012. I may not get through everything in the analytic functions, but my slides are available on my blog. They're posted today, and they'll be when we get to the end of the slides, we'll see, I'll post the address again if you need to see it. I have that already posted, the slides and the code, and I'll be answering questions in a blog probably tomorrow. So what are window functions? The way I like to think of window functions is that I have a query that has results, a set of rows that is going to return to the client. Before we return that data, we can define a window, or I kind of think of it as looking through a window at that data, and we can perform some calculations on that data. So I can define one big window that looks at all of those rows, or I can even define it more granularly in what's called partitions or framing. Framing we'll get to much later in the talk. So how do I know when I'm looking at a window function? You'll see the over clause. The over clause is used for a couple other things, but if you see that over clause in the select statement, it's almost always used with a window function. We have some other things like sequences that use over, but generally, if you see the word over, you'll know it's a window function. So where do window functions go in my query? They can only go in the select or the order by clauses. The reason for that is that these operate on this data that's almost ready to be returned to the client. The from, where, group by, having clauses have already done their work before the window functions get a chance to do their thing. We can also, instead of having just one big window of all those results, we can also divide that window up into partitions. And I do that based on a column or a number of columns. And then I can perform a calculation or use a function. This is not the same as a group by. So if you think about group by, if I have data and I want to group by customer ID and get a sum of total due, I'm going to get back one row for each customer along with that total due. I'm not going to get the details. So with window functions and partitioning, I'm going to get those details back along with my calculation. The first group I want to talk about is the ranking functions. These have been available since 2005, and I suspect that probably the majority of you have at least used row number or have heard of row number. Row number provides a unique number over the window or over the partitions. Rank and dense rank are very similar to row number. However, the number that we get back is not necessarily unique, because if there's some tie in the data, some values that are the same that we're applying this row number to, we'll get some values repeated. And there's also a ranking function called intile. Intile allows you to divide rows up into buckets, and not quite the same, not really the opposite of the others, but very different. So let me just walk you through an example of how row number works in case you haven't seen it before. So I have some data here. This data is not out of AdventureWorks, it's just some data that I made up. I have a customer ID, an order ID, and a total due. Let me go ahead and sort that data by the order ID. That's all I've done here. And now I'm going to apply row number. So I'm going to apply row number, and when I do that, I have to specify an order by. How is that row number going to be applied to my data? That order by has nothing to do with how the data is presented to the client. I could order it, a final order by clause on the query could be in a totally different order. So you'll see I get back a number, unique number for each order in the order that it was in the order of this order ID. I can change this value if I wanted, or this column if I wanted to apply those row numbers in a different way. What I also can do is partition the data. That's not the same as group by. So when I partition the data, I'm going to break it up into smaller windows. Okay? And for each particular row, when I apply my row number, I have a particular window that I am going to apply that row number function to. So now, when I use a partition by, so I'm going to partition by customer ID and then order by order ID, this is how my row numbers look. I'm going to start over for each customer. So how do I tune these? How do I make sure I get the best performance out of these? Well, one interesting thing is that there's a new operator. So if you're one of the people that like to look at execution plans to help you tune your queries, you'll see a new operator called the sequence project operator. I find the definition a little confusing, but basically it's adding columns to perform computation over an ordered set. Okay. Whenever I use one of these ranking functions, and also the other window functions, or most of the other window functions as well, I'll see this sequence project operator. So if I want to make my query using one of these ranking functions to perform as well as it can, I'll need to create an index. It can either be the clustered index for the table, or it could be a non-clustered index. I want to make sure that the first column in that index key is the partition column, followed by the order by, and then we want to include any extra columns we need to make sure that that is covering. If there's a filter in the query, then go ahead and add those filter columns first before that partition. The other thing you want to make sure is watch out to make sure that you're not doing any reverse direction. So what I mean by that is let's say I added my index, but then whenever I wrote my query, I used the word descending, the keyword descending, and basically, even though I have that index, I ordered it in a different order. That usually kills the performance on these. So do I want to add this index on for every single query that I might use row number? Probably not. Just like any good index tuning, you want to look at the usage. Is this a query that runs okay, good enough, and you're not going to run it all the time? You probably don't want to mess around adding another index. Trust me, I have been on a couple different index tuning projects in the last year, and primarily there's too many indexes. It's rare that there's not enough. Occasionally you'll add a new index, but usually you have too many. So you got to be careful that we don't just start adding lots of indexes just because the slide said to get the best performance on this query to do it. You got to think about the big picture. So let's go ahead and look at some examples. I am going to use the AdventureWorks database. Let me go ahead and bring that out so this is more in the middle. I'm going to use the AdventureWorks database because it's easy for you to download and use, and then there's data there. So this is I'm just going to run through some of these quickly. This is just using the row number. Every time I use row number, I have to specify an order by, and I get back the row number in order of that sales order ID. If I want to use partition by, if I want to have those queries, want to have those row numbers start over with each customer, I can add my partition by. I'm going to go ahead and look at statistics IO on, and I'm also going to turn on the execution plan so we can take a look at that. So I've got one scan count and logical read 686. I'm going to copy that and put it right here. And let's take a look at the execution plan. So I see that sequence project operator that I talked about, but I also have a really expensive sort. Okay, I'd like to eliminate that expensive sort if I can. So this is assuming that I need the best performance possible for this query. I'm going to create a non-clustered index. So my cluster key is actually sales order ID, so I don't have to include it here. So customer ID is my partition column. Order date is my order by column. I also need the sales order ID. I don't have to worry about that since that is the cluster key. If that doesn't make sense, go back and look at some previous training on the T's where I talked about indexes. So now I'm going to run this query again, and we're going to see the difference. Now when I look at it, I see a scan count of 1 again, which makes sense. I don't have a where clause. I'm looking at the entire table. But a logical reads of just 88, where before it was 686. So I really improved this query a lot. If I take a look at the execution plan, you'll see that that expensive sort is now gone. I can also show you some quick examples using rank and dense rank. Basically what happens is if there is a tie in the data that is, and it's hard to find them, data that actually is duplicated. Here we go. Here we have the same number over and over and over for the total due. So instead of just applying unique numbers, what we're doing here is repeating. We've got a tie, just like if you were in a race and two people come in at exactly the same split second, then they tie. Eventually, here we go. What I wanted to show you is after all those duplicates, then what it's going to do is skip all of those numbers and jump to the next value, okay? Just up to the very next value that it would have been if it had been row number, okay? Dense rank is very similar, except that we are not going to skip. Here we go. Here's an example of some ties. Dense rank is different in that, excuse me, we're not going to skip any numbers. We're just going to start numbering again, okay? And finally, I want to show you an example with InTile. So here's an example. I have my salespeople in AdventureWorks, and I want to give them a bonus based on their sales. So I have my InTile function, and I have to specify how many buckets I'm interested in. I've got the over clause. I've got to have my order by, and then I'm going to multiply it by 1,000. So all my salespeople that end up in the first bucket are going to get a $1,000 raise or bonus, and everybody in the second bucket are going to get $2,000, and so on. So that's how it works. So basically the answer here is either 1, 2, 3, 4, and I've multiplied it by 1,000. So as I promised in the description, I'll show you some interesting applications that we can do with row number. And in fact, I start thinking of row number every time I get a query that seems a little tricky. I often just add a row number just to look for patterns. So what I've got here is a temporary table with some duplicate data. So maybe what you have is some data that you have to pull in and clean up. Pull in from a text file and clean up before it gets loaded. So I have some duplicates here, and I have some duplicates here. How can I get rid of those? Often you'll hear, well, add those into another table with a group by or a unique, not unique, but distinct, and then throw them back. But instead of doing that, I can actually write a query that will delete the rows I need. So when I was figuring out how to do this, the first step I did was just add a row number to my data. Well, when I do this, I see that I'm making my data unique. What was returned to me is now unique. But the problem is I don't know what kind of pattern, what do I need to get rid of? I want to get rid of something based on this row number, and I don't really see what to do. So my next step was to go ahead and partition it by the columns. And when I do that, now, again, I have unique data that I'm looking at, but every unique combination has a row number of 1. What if I deleted everything except the rows that have a row number of 1? So let me just take a look at that. Oh no. Remember, I can't do that. I can't put, let me show you what I ran here. I did that pretty quickly. I cannot put row number in the where clause, because remember, that window that we're looking at, that window we're doing the calculation on, is after the where clause. So I can't do that. So what I'm going to do is use another technique that was introduced in 2005 called common table expression. If you don't know what a common table expression is, go out and look at my blog. I have a couple of blog entries on this. So this has been around since 2005. So what I can do is define another query, and then in my outer query I can filter. So I've got this column. In my outer query I can now filter. This is the data I want to see. Or actually, I'm sorry, this is the data I want to delete. If I change this to equals, this is the data I want to see. Okay. So the way I'm going to do this is I'm going to use my common table expression and then delete from that common table expression where the row number doesn't equal 1. And let's see if it worked. And it did. So this is my unique data that I was hoping to get, hoping to clean up. And it was pretty easy to do. Okay, another thing you might use row number is if you need to find like the first set of orders over a group. You can use top and use a correlated subquery to do this, but this is another great way. So again, I'm using a common table expression, or you could use a subquery if you wanted, and I'm going to filter on row number. So now what I have left is the top, the top 4 sales from each year. Actually by date, so that not really the top, the first 4 orders in each year. So if I had changed this to total due, or is it total due here instead of order date, like descending, I could have gotten the top, the best orders. Another thing that we can do with row numbers is the islands and gaps problem. So what I've got here is a little table, and I'm going to insert some data into it. And by the way, are you familiar with this syntax, where instead of, if I want to enter a whole bunch of rows at the same time with hard-coded values, I can do it like this, and this is called a row constructor. Instead of doing select 1 union, select 2 union, or creating a whole bunch of insert statements. So this was introduced in SQL 2008. So if you're not familiar with it, you've learned it today. So what I would like back, let's see. Look at the data here. So I have the data, and what I would like back is the results like this. My first island is 1-3. My second island is 5-6, and so on. So this is the results I would like to get back. So the way I like to solve problems, like I said, if it's something tricky, I'll just go ahead and add a row number and see what happens. So I'm going to add my row number and look at the data and look at the relationship. So I'm like, okay, well, I've got a 1 here and I've got a 1 here, and 2, 2, 3, and these are just, so this right here is just counting up, but here I've got my gaps. Oh, wait a minute, look at this. 5 and 4 are matching up. 6 and 5 are matching up. This is the same number. This is 1 different. Right here, it's 2 different. So that gives me an idea. Let's look at the difference between the column and that row number. So what I do, it's just as I was calculating in my head. So what I can do is use this row number column as a grouping. So the way to solve this is to use min and max and group by that grouping. And again, I'm going to have to use a common table expression because the grouping takes place before the window functions work. So let me go ahead and run this. And now I've got the results. So I've got my islands. And this is a very common, I'm going to say, technique that is used. Lots of problems require this. I'm going to go back to the slides and move on to the next item. The next item is the window aggregate function. So when I've been out there talking about this, a lot of folks are familiar with row number, but they haven't heard of window aggregate functions. So what are they? Window aggregate functions are just your favorite aggregates that you use every day: sum, min, max, average, etc. But with no group by. We're not really working with an aggregate query here. So we can, I'm not going to go that deep in this, that kind of is another tangent, but basically this allows me to add an aggregate function to a non-aggregate query. So we're going to look at that window. We're going to do a calculation over the window of results. We are not going to force the other columns to be grouped. We can either do our calculation over the entire result set, or we can do calculations over a partition. There's one gotcha with this. The pre-2012 functionality, and remember, this is stuff that came out in 2005, has no performance optimizations. You could possibly get a decrease in performance by using this. However, on the other hand, if it's a query that is not something that's run at an extremely frequent basis, or the query runs good enough, the performance is good enough, then this is a great thing to do, because it can make your query writing so much simpler. So unless it's something, if it's something that you absolutely have to squeeze the most performance out of it, then you probably don't want to do this. So let's walk through an example. I've got my data. I am going to calculate, so a sum of my total due, followed, and I've got sum total due. Now, if I normally just had sum total due, I'd have to add a group by, okay, by my other columns that were in the query. In this case, I don't. But if I include the over, I don't have to add the group by. So whenever I specify over with empty parentheses, that means perform that calculation over that entire result sets. So when I'm on that first row, I'm going to perform a calculation and add up all of those total dues. Total dues, I guess. Okay. I can also partition. So when I partition, I am going to perform my calculation inside my partition. Okay? I almost like to think of it as window panes. I've got my big window, but now I've got these divisions, these other small windows. So for every row that I'm on, I'm going to perform a calculation, and I know that this is the window that I'm going to perform that calculation on. So let's take a look at some examples. So here's an example where I am getting some detailed data from the sales order header table. I'm getting that detailed data. There's no group by, but yet I was able to get a total, an overall total. So what I might do is I might want to have some calculation where I find out what percent this is over the entire sales, something like that. Let's take a look at that again, and just to get an idea of what's going on. So what SQL is doing is creating a work table that is stored in TempDB. Okay. Unfortunately, there is another thing that's going to happen once we start talking about the 2012 functionality that looks the same in this window but is very different. So we've got a logical reads of 64,000, and we scan the actual table once, but then we scan this work table 3 times. So there's a lot of work being done. If we take a look at the execution plan, we'll see this table spool operator. That's what's saving that data into the temp tables, and it looks like a lot of the work is done joining these back. Okay, so just keep that in mind, that we are not getting fantastic performance on this functionality in particular. So I can add a partition by. So if I do that, then we'll see that for this particular customer, I've got a total of their sales. So the cool thing about this is it's just really easy to do. You know, just add the sum and add that over clause. And now we're performing that operation over that window instead of adding a group by and performing it over groups. Okay, so let's take a look at performance again. Here is another way that I might write this query using a subquery, and actually a correlated subquery, where the inner query is, you know, filtering on the outer query. Okay, so let's take a look. Let's take a look at both of these together. So what I want to do is compare this one to this one. So we can see that the first one is actually better performing when we look at the statistics IO, which is unfortunate. I wish that there were some enhancements to make this better. If we take a look at the execution plans, at least the execution plans are saying, well, they're, you know, not too far off. They're not too far off, and in fact, they're saying, in this case, they're saying that the newer way to do it with the over is actually a little bit better. So you may or may not get better performance. And it doesn't seem to matter whether you have this particular index or not. It doesn't seem like it made as much of a difference here. So am I saying write these off? No, absolutely not. This is such a cool technique, especially if it's a one-off, or, you know, again, if it's something that has to have absolute perfect performance, you may not want to do it. You may want to do some testing to find out for sure. But it's really cool for something like this. So here's a query that one of my coworkers sent me, and it's already kind of complicated. And what they said was, and I don't have, this is actually looking at the row count over partitions. And I actually don't have much partitioned in my AdventureWorks database, but you can see how this works. So they came to me and said, we want to know for each partition what is the percentage of rows overall for that table. And they couldn't figure out an easy way to do it. So they sent the query to me and asked for some help. So it was really easy and took me like 3 seconds, because I am familiar with this technique to just change the query to this. Take the row count, multiply it by 100 since it's a percent, and just use the sum of the row count along with over, and we're going to partition by object ID. Object ID will be my actual table. So it took me about 10 seconds to figure that out, and it gave them exactly the answer that they were looking for. So it's super cool for doing things like that. You just have to be careful about the performance if the performance is your highest priority here. Okay, well, let's jump back to the slides. One thing I want to mention, everything that I have demonstrated so far up to this point, I'm going to draw a line here, is 2005 functionality. With the exception of where I was using the row constructor, that's actually 2008 functionality. The row constructor is where I was adding a whole bunch of rows at a time with one statement. So here on, it's 2012 only. Okay, hopefully some of you remember the $6 million man. He wasn't an accident and got damaged, but they not only fixed him, they made him better. He could run really fast. And when I'm at an airport and I am walking on one of those people mover flat sidewalk things and I'm walking on that, I feel like him. I feel like I'm going really fast. So I'm not saying that SQL was broken or damaged. It wasn't. But the fact, I just thought of this when I thought about enhancements, that what we're doing here is enhancing these functions to be even better than before. Okay, so the first thing that we got in 2012 is that we are now able to add an order by clause to the window aggregate. So when I first heard about this, I was like, what? Well, what in the world is that going to give us? You'll see in just a minute. Now, when we add that order by clause, we now have a performance optimization to make this run really well. So that index I talked to you about earlier, where you can have the partition plus order by plus any covering columns, that applies here. And the performance is really, really good, really, really better than other ways that you can solve the same problem. You're still scratching your head saying, what problem are we talking about? Trust me, I'll get to it in a minute. We also have some other enhancements to these window aggregates where we can add something called framing. And framing allows me to further define the windows. Okay, so let's walk through an aggregate order by example. I've got the same data here. I'm going to sort it by order ID. And for each row, I'm going to have a different window defined. So for the very first row, that's my window. My partition for that row is right there. For the second row, here's my partition. For the third row, here's my partition. So I've got these overlapping partitions. You know, that's allowed. Every particular row has a different partition, and it consists of all the rows plus everything behind it. So here's what it looks like when I apply this. I'm going to get a sum total due over, and I'm going to order by the order ID. Okay, so my window, as I said, my window is now, for a particular row, every row behind it as well. So do you see what's going on here? Hopefully most of you noticed I'm getting a running total. So that's what this will do for me, get me a running total. So when I'm on this row, I get the total of everything in that total due column. That's this row plus everything before. So let's take a look at this. This is one of my favorite things. I'm going to go ahead and create a non-clustered index to make this perform better. Again, we're going to do the partitioning. Let's see. Oh, actually, yeah, the partitioning by customer, the order date, and then I need the total due for my covering column. Again, sales order ID is part of the clustered index, so I don't need it. So I'm going to go ahead and add this so that I have the best performance I can get. So here's a way I could do this with an old method that's pretty popular. I can do a correlated subquery, and I'm using a less than or equal to. This does not scale. It works fine with a small set of data, but it will not scale. It will just get worse and worse. And here is the same query, but written using the new functionality, the functionality that's available in 2012. So let's go ahead and run that and take a look. First, I want to look at the I/O. The really disturbing thing and the confusing thing to me for a long time is that it looks like the new functionality performs worse. We have a work table that's getting scanned 50,000 times instead of 30,000 times, and we have 188 logical reads instead of 67,000 logical reads. So hey, wait a minute, didn't I just say this performs better? Well, let's take a look at the execution plan. So what it's saying is that the old method is taking 97% of the batch. That's quite a bit. And the new method is taking 3%. Okay, we know sometimes this lies to us. For example, if we have a user-defined function or something like this. We don't have a user-defined function this time. We've got a legitimate built-in function, so there's nothing crazy about that going on. But there is something different. Notice that instead of having a table spool, I now have what's called a window spool. So what's the difference? The difference is that window spool allows my work table to be created in memory instead of in tempdb. So that's the performance enhancement. Not only am I getting rid of, by using a particular index, I'm getting rid of a nasty sort, an expensive sort, but by using this window spool instead of a table spool, I'm able to get really, really good performance. Okay, I've got a little bit left to cover. I'm not sure how far I'm going to get because there is a lot of, this is really supposed to be a 75-minute talk. Okay, the framing. This allows us to define the window even further, and there's some terms we have to use, and we kind of create a phrase with these terms. Unbounded proceeding. That means if I'm on a particular row, everything behind me. Unbounded following. If I'm on a particular row, everything ahead of me. Current row. That's pretty straightforward. That's the row that we're on right now. I can also specify a number of rows preceding or a number of rows following. We have rows and range. Rows has been fully implemented according to the standard. Range has not been fully implemented, and right now they do exactly the same thing. So the advice that I've seen is actually from Itzik Ben-Ghan, and he has an entire book on window functions. He's saying just ignore range for right now until Microsoft adds that additional functionality. So this is a screen where I lose people, that people get confused and go, huh, what's going on? So let's talk about it a little more. If you know me, you know that I love going upstairs. I love stair competitions. So I've got this athlete here. He's running, we used to do this in track team in high school. He's running bleachers. So we've got steps that he's going up. I can have a term called rows between unbounded preceding and current row. What the heck does that mean? What that means is that it's all the rows that he's already been on plus his current row. So I'm going to do a calculation for everything behind me. And in fact, that is the default if you don't specify anything where framing is allowed. Rows between current row and unbounded following. That means the row I'm on plus everything that's ahead of me. Rows between two preceding and current row. That means the two I've already been on and the row that I'm on. Here's another example. Rows between two preceding and 5 following. So that's the rows 2 behind me, my current row, and the 5 ahead of me. Hopefully I counted those right. So hopefully this graphic helps you understand what these phrases mean. So let's do a quick demo. I'm almost out of time. Hopefully I'll get through most of this. So let's run this one. This will really show you the difference. Here I've got, let me pull this query up so you can see it. Here I'm using rows between unbounded preceding and current row. That's everything that's come up behind me. This is also the default. So if I don't include it, if I include this or just leave it out, leave it blank, my default is a running total. If I say between current row and unbounded following, what's ahead of me, I get a reverse running total. So let that sink in. Come back and watch the video again if you're still confused on this. I can also specify a number of rows between one preceding and current row. So I can show instead of a running total, I've got a total of the last 2. All right, we got a little bit of time to cover the last bit. The analytic functions. Hopefully this reminds you of some professor that you had in college or some instructor you had in high school. I had a teacher that could write on the board with 2 hands at the same time or write with one hand and erase with the other, and this kind of reminded me of him. So we had some analytic functions, new functions that have been added to T-SQL 2012 that really depend on all the things that you've learned up to this point. Lag and lead, first value and last value, and I probably just have time to look at those. And then we also have some other ones concerning percentages that I might not get to, but they have to do with more statistical functionality. And I have blogs written on all of these topics. So let's take a look at that demo. Lag and lead. So what lag and lead lets me do is take a peek at a value from a previous row. The framing is not supported, so that rows between, unbounded preceding, all of that is not supported with lag and lead. So what I've got here is I can say lag whichever column I'm interested in looking at. It doesn't have to be, I keep messing that up, it doesn't have to be anything in my over clause. So I'm going to order by order date, but I'm going to look at the last order, the order that was previous, and pull out that sales order ID. I can also use lead to look into the future, look at the next order. So let's go ahead and run this, and I'll show you what I'm talking about. So I have my first customer here, and when I'm on this row, I can see what my previous order number was right here. So I'm taking a peek at that. To do this without lag and lead is very difficult before 2012. Performs, usually you'd have to do some kind of a top one with a join on itself, really, really terrible performance. If I'm on this row, I can say here's my previous order and there's my last order. So that's how it works. I can use this in calculations. So in this case, I can see how many days since the last order. So here's my previous and next, like we talked about. How many days since the last order? How many days till the next order? Okay, very, very, very cool functionality. There's also some optional parameters. An offset, so in this case I look back one row. I could look back 2 rows. If I had my data grouped by year and month, I could actually do something where I looked back 12 rows to find some value in the previous year in the same month, something like that. So let's run that very quickly. Here's a default. Instead of those nulls that come up if there's no order, there's no data that many rows back, I can supply a default. So there's my default. If I want to go back 2 orders and there's nothing to go back to, I can have a default if I want. Another one is called first value and last value. So when I first heard of this, I thought of min and max. I can get the minimum value and the maximum value, but this is different. I have my data ordered, order by order date, and I can pull out any value that I want. So for the very first order, what's the total due? For the very last order, what's the total due? In this particular one, that unbounded preceding and current row, all that framing functionality is supported. So if we don't say anything, it's going to be everything in past, or we can specify. So this one is, so if we are looking for last value, then we must specify, because otherwise we're just going to look at the values that were behind us. So if it's last value, we must specify rows between current row and unbounded following. What's ahead of my runner there? What's ahead of my row? Clicking the wrong thing here. Okay, so this is telling me this is telling me my total due. My first total due, this is telling me my last order date. So it's actually, I'm looking at a different value. Okay, looks like I've got about 4 minutes so I can take a look at a couple of the new percentile. So we've got percent rank and cum dist, which stands for cumulative distribution. So if you think about, maybe you took some standardized tests like the SAT or the ACT or something, and you get back something and it says you are at the 90th percentile. Okay, so what does that mean? Well, I'm not sure when it comes to those tests, but if we're using percent rank, what that means is if I'm at 90%, my score is higher than 90% of the scores. If it's cumulative distribution, what that means is my score is at 90. I'm not higher than 90, I am at 90. I'm actually better than 89. So let's take a look at that very quickly and we'll see the difference. So what I've got here is one particular year and the sales by month for that particular year. So then I'm getting my percent rank and my cumulative distribution for both. So you can see there's a difference. When I'm on this row, this means I am better, May is better than 45.45% of the months, but its actual position is at 50%. So that's how those work. And I'm now on the very last. And this one is a little tricky. What I'm actually doing with this one, percentile, I don't know how to pronounce it, so I'm not going to try. And percentile disk, no window frame supported. Basically, I start out with a percent, and I go backwards. If I have a value, a percent, what value lines up there? And again, it's a little different. The first one will return a calculated value. It doesn't have to give you the exact value. It'll perform a calculation. The second one will return an exact value from the data. I also have this new within group clause instead of an over clause. So basically what I'm saying, and maybe you have to be a statistician to really get this one, what I'm saying is for 50%, I've got the same data. What is the value at 50%? This one actually does a calculation. It finds the value between these two and comes up with the average. If there was an odd number of values here, it would pull one of them. But since there's an even, it's going to do a calculation. This one will pull an actual value.
Kathy, we just reached 12 o'clock.
Okay. I'm going to just show this slide up here for them to go out to my blog and get the code and slides for this, and I guess I got done just right on time.
Perfect. Yes, and we did have a lot of questions about that. Let me just reiterate. Our sessions are recorded and will be made available by the end of the day tomorrow. If you go to pragmaticworks.com, go to our Learning Center, and you can find all of our past webinars under past webinars.
Right, and I'll have the answers to all the questions probably within 24 hours out on my blog as well.
Wonderful.
Thank you very much. Thanks for everybody for attending.
All right, thank you guys, and we will see you guys back on Tuesday for more free training on the T's.